So today, lesson number 25 is all about exponential models. So using the exponential equation or function and using percents, which we've done for the last couple of lessons here. So learning targets will be to know the difference between growth and decay. So how something's increasing and decreasing, but we'll use different words for that, growth and decay, and to be able to evaluate an exponential model involving percents. So how we represent these numbers as a percent will be very important. Let's get started with what we talked about last lesson. So again, here's your chance to get caught up if you didn't come last class or if you didn't do the practice assignment. When we look at a number like 100, whoops, let me get my marker working here. When we look like a number like 105, all right, that is really representing 105%, because we can move that decimal twice and make it a percentage. Now, what increase is that? Well, that's a 5% increase, because whether it's 1 or whether it's 100%, the extra part is what it's growing by. And in that case, this is a growth because it's over 100%. It's over 1 in that regard. Now, the next number here is a little bit more complicated, but again, focus on the second half here, where if we move that decimal 2 times, it would be 114.7%. Now, some people say that's a decimal and a percent. Well, it's actually just a percent. There's a decimal in it. The percent sign is really telling you that's the percentage. Now, focus in on just the second half here, where this is 14.7%. Focus on this part because that's the amount more than 100, more than 1. All right? And again, because it's over 100, we call this a growth. Just trying to get used to those new words instead of increase and decrease like it was last class. Next up, 0.96. Well, that's really 96%. Now, how far from 100% is that? Well, that's 4% from 100, right? So if I added the 4 to 96, I'd end up at 100. What the 4% represents is a decay, how much it's going down. So obviously in nature, when a tree falls in the forest, it doesn't just sit there and ends up decaying. It's part of our nature, part of our ecosystem where it's kind of cool that the earth is constantly kind of trying to regrow and regenerate, but also at the same time things have to decay and decompose to allow other things to proceed. So really cool earth science topic there that I'm sure you've gotten into this year. Next up, let's talk about 0.832. Again, as a percentage, 83.2%. Now be careful here of how you get back to 100. I got to add 8 tenths on. So 8 tenths to 2 tenths makes it 84, and then another 16 to get to 100. So 16.8% is going to represent the decay. So that's how much it was going down. That's how much it's come off. All right. No questions so far, so I'm going to keep going, but please, if you have any, let me know. I'm going to go a little faster here. What if they just say that it's a 5% growth? Write it as a percent, then as a decimal. Well, again, add it to 100. This is going to be represented as 105%, but we don't use the percent in math. We use 0.0 or 1.05. We got to use that decimal value. We do it again with 7.5%. Again, this is a percentage. Add it to 100, like we did last class, 107.5%. Now, as a decimal, kick it 2 times to the left, 1.075. And anytime we multiply by 1, it keeps that amount. The additional part, even though it looks small, will bring that value up. Now, what about a decay? Decay is just like decrease, where if it's a 5% decay, we're really talking about 95%. Again, that's how much remains, and so that's 95 hundredths. And you could always use your calculator with finding these out if you're having a little bit of a difficult time with the subtraction. But 100 minus 14 brings us to 86. I got to take that extra half off. So this is really 85.5%. Kick it 2 times for 8.855, 855 thousandths as a decimal. If you've ever left a piece of fruit out, banana, orange, or something, and it started to kind of get old and rotten, fruit flies suddenly just appear. It's the most ridiculous thing, but yes, you can grow an organism right out of an old, dead, rotting piece of fruit. So fruit flies will appear and they will grow at a constant rate of 6% per hour. Gross. Now, let's say we start with 28 fruit flies. Let's come up with a way to figure out how many fruit flies we're going to have at certain points. So using what we learned in previous lessons, determine a percent increase. Start with 100% because that's going to keep the fruit flies. These are going to grow. Add the 6%, and so it's going to grow at 106%. So use that number instead of 6% and then adding on that amount to 28. Now we want to write it as a function, and we want to write it in terms of a exponential, where it's the y equals a times b to the x power. Remember that one from before break? Well, we're going to change the output to p because that is the population. We're going to put a number or a letter that is in parentheses. This is just function notation. We should be familiar with this. The a is the starting value. So that is 28 fruit flies. So that number goes first, and then we're multiplying by the percent increase. So the 106%, and then because this is an exponential, it's got the word exponent right in there, it's going to have a variable for an exponent, and that is t, which we're going to learn is the number of hours. Now, I don't actually use this particular model. I have to use the one with a decimal. So I'm going to move that decimal 2 times. Try to evaluate P24. Now, what does that tell the reader? We want to know the population after 24 hours. Okay, 24 hours. So we go P parenthesis 24, which means we write the same 28 parenthesis point or 1.06, but now we put 24 in for t, the amount of time that we're trying to evaluate. If you'd like to, you can go through the process of figuring that out. It might take you a couple hours. Instead, let's go to the calculator. Okay, this will make everything so much faster. So type in everything to the right of the equal sign. 28 parenthesis 1.06, close the parenthesis. Remember, whatever I press, it turns red. So I'm going to use the up arrow here and 24. So 24 hours or 1 full day. If we started at 28 fruit flies, we're going to have 113 of those little bugs flying around our gross fruit. So P24 equals 113. Now, what does that represent? A lot of people don't kind of understand that language, that math language, so I've written it out for you. There you go. So if we look at the next part where we're asked to graph, we are told what we want to see. So this is only the first quadrant. This is where you do a lot of your science graphing because everything's positive. And this compound inequality over here isn't anything more than just saying go from 0 to 24 on the t-axis. Now that's usually x, but this is hours or time, and I knew that because they had a t right here. Now this one is a p, so I know that this axis that's labeled p goes from 0 to 120. It's just telling us what we want to see. So bring up your calculator and go to the window. Now our standard window is -10, 10 to the left, 10 to the right, 10 down, 10 below. But I want to change that so that it starts at 0 and goes to 24, so 1 full day. It wants to go by ones, and then it starts at 0 and goes to 120. All right, so once we've got that in your calculator, press the y equals button. And this is where we enter equations. You're just going to enter everything to the right. So that started at 28 fruit flies and it was increasing at 1.06. Close the parenthesis, press the up arrow, but this time don't put a number, put in x, because this is going to give you the values for all x values instead of just one x value. Now we want to see the graph of this. So now that it's entered, press the graph button, and there it is. Like we talked about the very first day, it's like an airplane taking off into orbits. All right, so back to the graph where I'm going to just start it right here at about 28 and then draw a curve that increases as it goes on. Do this by looking at the table in the calculator. So press second table and it will pull up all of the x values and all of the y values. Now we want to exceed, let me get my notes here, 250. Now at 13 I'm at 59 and at 14 I'm at 63, so I got to go down a little further. But you're going to notice that as I go down in x, which is really going up in values, I'm pressing the down button, the y values are increasing very quickly, and they will increase and eventually get to 250, and there it is on the, oops, don't keep going, don't do this. So using that table of values, we can identify that on day 38 we reached 256, which exceeds the 250 fruit flies. All right, question number 2. Another one where it's a real-life application of a decreasing or a decaying situation. A pool is being drained so that we can winterize it, and it's decreasing at a constant rate of 9% per hour. Now, if there's 12 feet in the pool when we started draining it, let's come up with a couple things. First of all, a percent decrease. So start at 100%, start at the full amount, decrease it by subtracting 9%, and yes, we're now at 91%. Come over and make an equation out of this. Again, an exponential is a times b to the x power, where let's do some function notation. D for how deep the water is, T for how much time, A for the starting value. This pool was pretty deep. Most pools are 10 feet. This one's 12. It's going to be decreasing at a rate of 9%, which means 91% remains. And we need an exponent, and let's use T, our input value. Now, we can't use that because that's a percent. As always, I have to change this to a decimal value. So there you have it. Change the calculator so we see the first quadrant, and we want to go from 0 to 20 on the t-axis. Where's the t-axis? It's labeled right here. From 0 to 20 and all numbers in between. And then again, this is just a fast way to write from 0 to 15 on the d-axis because there's a d in the middle there, and so highest is going to be 15, which is like, that's not that much, but there's 15 feet for the y-axis as a height, but we only end up with 12 feet of water instead of 15, and it's going to be decreasing, so we don't have to go any higher than that. Well, let's get to the calculator, and I'm going to have to change some things, which means we start with the y equals. So let's get rid of this equation and enter in our new one, which started at 12 feet of water and multiplied by 0.91, close your parenthesis, raise it on up to the x power. We want to go from 0 to 20, and then we want to go from 0 to 15 for the y-axis. Go ahead, press the graph button, and you're going to see a plane landing, right? It's going to start up at 12, and it's going to gradually come down. So y-intercept of 12, gradually come down and get to, around 0, but not ever going below 0. So it's safe to cover the pool when it's 5 feet or less, and the best way to figure out how long you should wait is to go to your calculator and press second table. Now I'm way up here at 36, which isn't good, so let's go second window, and I'm going to change the table start, and let's start back at 0, okay? Now when I go second table, I'm going to start at 0 and see 12, and I'm going to go down, which is going to increase the x value until I see less than 5 feet, which happens right about the 10th day. So on the 10th day, you can cover up your pool and be below those jets.